In this video, we'll discuss implicit solutions, which sometimes are a necessity when it comes to solving separable equations. So ideally, whenever you're solving a differential equation, you'll always be able to write out the answer as an explicit function. So if we're dealing with y and x, you'd be able to write out y as a function of x. But sometimes that's just not possible. It happens a lot with separable equations. So this gives rise to trying to distinguish between explicit solutions and implicit solutions. So an explicit solution means that you can set it up so you can write y as a function of x for that solution. That is, you're able to solve out to get the y by itself on one side of the equation and everything next all on the other side. The contrast here is an implicit solution, where this is not possible. In this case, you'll usually end up with something like some function of both x and y equaling c for your answer, or some arrangement where you've got x's and y's sort of scattered all over the place and you can't get a single y by itself on one side of the equation. So here's some examples of this, and with it, sometimes it's possible to correct this issue and get to an explicit solution once you pick an initial condition. So let's see what this might look like. So we're going to take dy dx is negative x over y, find the general solution, and then find some particular certain initial conditions. So this is a separable equation. Right, if I have dy dx is negative x over y, I can multiply the y to the other side, then move the dx around to get that y dy equals negative x dx. I can integrate both sides to get that y squared over 2 equals negative x squared over 2 plus c, or I can add the x squared term to the other side to get that x squared over 2 plus y squared over 2 equals c. Now that's the best I can do for a general solution. And why is that? Well, I could try to solve out for y, but if I take this expression up here and multiply through by 2, I get that y squared equals negative x squared plus 2c, and I can take the square root of both sides to get that y is equal to plus or minus square root of 2c minus x squared. I can absorb this to be just a c, but it's fine right now. What's the issue here? The issue here is this plus minus. At this point, with just what I have here, I don't know if I want the plus or the minus sign. Because right now, this is not a function. It has a plus minus, it has two outputs for every input, one with the plus, one with the minus, therefore it is not a function. But once I pick my initial condition, then I can go towards figure out which one that I want. So for instance, if I start, say, back over here, and I want y of 0 to equal 3, well, I plug in 0 for x and 3 for y, I will get 0 plus 9 over 2 equals c, so c is 9 over 2. And then implicitly, my solution is x squared over 2 plus y squared over 2 equals 9 over 2, or x squared plus y squared equals 9. I can now take this and solve for y, to get that y equals the square root of 9 minus x squared, so with the plus minus. But because I know that y of 0 is positive 3, I know that what I want here is the plus sign, because the minus sign would give me negative 3, and that's wrong. So now that I know that I have this condition here, I know that I pick the plus sign, and now I have an explicit solution here, once I've picked my initial condition. The same goes for the second condition, which was y of 0 equals minus 2. I do the exact same process. 0 plus plugging in negative 2 is 4 over 2, or 2 is c, so c is 2, which gives me that my solution that I want is x squared over 2 plus y squared over 2 equals 2, or x squared plus y squared equals 4. Solving out for y gives me y is the square root of 4 minus x squared with a plus or minus sign. But now, since I know that I want y of 0 to be negative 2, what I want here is the minus sign. Explicit solutions come about when you can't solve out for y in the expression, and sometimes, in this particular case with a circle, where you have sort of two halves, you can pick which one you want once you know what your initial condition is. It's helpful to know that an expression of this form here, that looks like with a c there and x's and y's all mixed around, would still count as a valid general solution, assuming that you cannot write it out as an explicit solution that you would want to do.